Hello, welcome everybody joining us. My name is Bob Mancini, and I'm thrilled to be here with my colleagues and friends, Jessica Berry and JP Drouin, to present the Decarb Refresh, Renewing Brown University's Roadmap to Decarbonization. So we're going to present this in two major parts, pre-2020 and post-2020. So in 2008, Brown University set an ambitious goal to reduce their greenhouse gas emissions by 42% by 2020. We met them in the spring of 2016, and from 2008 to 2016, they had accomplished a lot, mostly on their electric side, and had achieved nearly 50% of that 42% goal. They brought us in because they realized that they needed to now pursue a strategy to help them reduce their GHG emissions from their district heating system. So we came in, we met multiple times across their stakeholder group. It was really a good collaboration among all of the stakeholder groups. We had a very good vision and alignment around the most important outcomes that Brown wanted to accomplish in this project. And at the center of it was a focus on results. It was a multi-year project, 3 years, in fact, and in the end, Brown achieved its goal by 2020.
I'm going to give a brief overview of what we are looking forward to after our 2020 goals. When we had engaged ecosystem on the thermal efficiency project, which you'll hear more about shortly, we were close to, we realized we were going to meet our 2020 goals, but we started to think about what is after our 2020 goals. And we, through a series of collaborative efforts across campus, we had landed on setting new goals of 75% GHG reduction by 2025 from a 2018 baseline, and then also a net zero along with decarbonization goal by 2040. This was all to be done with minimal offsets, and I'll talk a little bit more about that later. Because this is such a transformative approach, particularly related to decarbonizing campus, we knew that there had to be extensive collaboration. We needed to be agile and flexible and really keep on top of new and emerging best practices and technologies. Next slide, please. Our approach to meeting these goals, the first, which seems to be the easiest, was we knew we needed to source our electricity from renewables. So currently we have 3 in-state solar projects and 1 out-of-state wind project. And those 3 projects combined will offset 100% of our electricity through about 2027. And after that, based on growth and electrifying campus, we know we're going to need to continue to expand our renewable portfolio in order to keep that 100% of electricity offset. We updated our building standards, so all new major renovations and all new construction are required to be net zero, so no on-site combustion, or they need to be net zero ready. So if they're connected to our central heating loop, they need to be prepared to receive electric-based heat. We knew that with these goals, we needed transparent and verified reporting. We landed on the climate registry as our reporting entity. So we now currently are third-party verified and report to the climate registry on an annual basis on our progress. The decarbonization roadmap is probably the most complex of all of these steps in our approach. This is really how we're going to modify our buildings and infrastructure and eventual electrification of our central heat plant that will decarbonize campus. And we'll talk a little bit more about the details on that in a bit. And again, as I said, We're doing all of this with very minimal, only absolutely necessary offsets, and all of those offsets are required to be verified. They must be additional, they must be permanent. Next slide. So now I'm going to turn it over to JP, who's going to talk a little bit about the thermal efficiency project. As I had mentioned, the thermal efficiency project was underway before we had decided what our new goals were going to be. And it became clear very quickly once we did identify our new goals that the thermal efficiency project would or could enable future electrification and decarbonization of campus. And so we worked very closely with the ecosystem during this process, or during the work for the thermal efficiency project, to be flexible and modify as needed the approach to thermal efficiency project to think about how this could enable our long-term, our new long-term goals for decarbonization. So JP?
Thank you, Jessica. Thank you, Bob. So I'll provide a little bit of additional information on the thermal efficiency project, and then we'll move to the next part, which is the more recent refresh of the roadmap for Brown. So, like Jessica said, the thermal efficiency project was undertaken before the full roadmap was fully developed for the university, and it was really targeted to reduce temperatures of the main thermal system at Brown, which consisted of a mix of high pressure steam, high pressure and high temperature hot water, and then low pressure steam, smaller hubs all around campus. And it generated water and energy savings and helped reduce the operating costs. But more importantly, like Jessica mentioned, it was an enabler. It was going in the right direction to lower temperatures of the loop and enable future electrification of the heating with heat pumps and therefore decarbonization. Although the TEP, as it's called, did not include any heat pumps per se, was really modifying the heating system. So working inside the buildings, inside the hubs, which are, you see the little peripheral loops, and as well as within the central heat plant. So creating a newly unified hot water district that's operating now at lower temperatures. It used to be operating between 275 and 330 degrees Fahrenheit. Now around between 200 and 250 Fahrenheit. And one of the goals was really to reuse a lot of the existing asset which was the backbone of the Brown main campus, the main high temperature hot water loop. There had been a lot of major investments in the previous years, and so the intent was to reuse a lot of these assets, and to do so at lower temperatures. Ecosystem and Brown, we had to re-engineer some of the loop and how certain buildings are connected to it. For instance, at the bottom of your screen, you see one complex which is now connected in series on the return of the loop to enable higher delta T's and keep the flow at a minimum. Next slide, please. This is one example of the many smaller measures that are included in the thermal efficiency project. Wriston Quad is one of the hubs in the peripheral, one of the peripheral hubs on the campus. It used to be steam, and now with some creative and innovative design approach ecosystem was able to reuse a high quantity of existing steam pipes from the previous low pressure steam network that goes around this Wriston Quad, which is a dorm or residential buildings, and turn it a lot of the existing pipes into a new hot water supply and return. So you see that the full lines are reused piping, and the dotted lines are new pipes that had to be installed. So that gives a sense for that part of the campus how much assets we were able to reuse, and that contributed a lot to the economics, the favorable economics of that project. Next slide, please. So for a cost of $25 million, $17 million of avoided costs. So a relatively small net cost, and that also delivered a lot of energy savings. So again, a great enabler for the electrification of heating in the future for Brown.
Yeah, JP,
Back to you, Bob.
I just quick to add on the delivery method, having an integrated engineering and construction way to deliver the project with guaranteed outcomes was something that was very important as far as making sure the results were there for the money spent and holding one company accountable for those results. So that's something that Brown has been doing for years. It's what we've been doing for years. It's one of the key synergies between our two groups. And so fortunately, they understand that method of project delivery, and they adopted that's what they use on campus. So that was something that worked to our collective advantage as well. Next slide. So now this is like the second part now, post 2020. We'll get into the refresh. We have the TEP, which set us up for the refresh post 2020. So I'll hand over the next slide to Jess to talk about that.
Great, thanks, Bob.
You're welcome.
So as I mentioned, the decarbonization, electrification part of our approach is really the most complex and transformative campus project that we've undertaken. This kind of touches every piece of campus. It's about 240 buildings, some which are quite large, and then some which are quite small. And so this really required us to have a wide expanse, a wide breadth of knowledge, have really experts in the room on all sorts of topics. And what we landed on was working with three different engineering firms, all that had experience and expertise in different ways. But it started to build this brain trust around this project. And so obviously Ecosystem was one of these firms. They had been with us with the TEP and for other projects. The idea was to bring these three firms into a room together for a full day summit and work together to collaborate on approaches and ideas on how our roadmap to decarbonization would look. And this was it could have turned into a pretty challenging format. You've got three different engineering firms, people who have not worked together previously in this capacity, three different firms that have different approaches, and likely for some uncomfortable engagement. And so one of the key components to the success of this summit was hiring a professional facilitator. This facilitator has worked with Brown in the past on many different projects, but it allowed for kind of a neutral party to navigate the ins and outs of the summit, and it also allowed the Brown team to engage fully in the summit and didn't require that the Brown team was managing the engagement that was happening. So that was really valuable. The overall goal of this summit was to exchange ideas and walk away with a variety of different approaches that could continue to be worked on and revisited, and form a basis for ongoing collaboration, and building out new ideas, best practices, looking at new technologies, and new approaches on this journey from the day one of the summit to 2040, and potentially beyond. Next slide, please. So I'm going to hand this over to JP to talk a little bit about the key technical outcomes of the summit. JP?
Thanks, Jessica. So as Jessica mentioned, the summit, which goal is to identify a roadmap to decarbonization for Brown University, is extremely complex. I mean, the challenge is extremely complex. I have to uncover to tackle solutions with respect to how you generate heat, distribute heat across campus, and use it inside the buildings. So it's a very complex and wide range of items. I couldn't go into every detail in this panel, but I'll go into. I'll give you a hint of some of the approach that ecosystem has been mandated with, which is the part inside the buildings. Other chapters are the generation and the distribution, and like Jessica mentioned, it was done through collaboration with other firms, and I have to say it was truly a great experience to collaborate with all the parties involved. And to this day, it's still going on. So inside the buildings, as you can imagine, one of the main challenges is to reduce temperature of the heating hot water inside the buildings to enable cheaper electrification through heat pumps and more cost-effective use of energy. However, the more you reduce temperature inside the buildings, the higher the disruption to the buildings and the occupants, and the higher the cost of the conversion. So this is, in a nutshell, the challenge we've been tasked with, as well as looking for ways to reduce energy waste inside buildings to increase general efficiency that would benefit distribution and generation. But really one of our main focus was to dissect, and our approach was really data driven. So because of our experience in the thermal efficiency project at Brown Ecosystem, we had a very good knowledge of the building systems. So we dove in and we developed ways to estimate the cost of converting the buildings at various temperature ranges of hot water. So if right now most of the buildings are designed and using hot water at 185 Fahrenheit, for instance, we're evaluating what it would cost and take to convert those systems to 170 Fahrenheit, and then 140, and potentially even 120. Like I said, there's no decision that's been taken yet. It's a very complex problem with many moving parts, but that's the thought process. And so looking at KPIs and trying to break down, next slide, please, trying to break down the problem into smaller components. So this is a very high-level graph showing all the energy on campus. We started by mapping the energy consumption on the heating side. So this is all campus heating energy in BTUs versus outside air temperature. So you see it's peaking in between 30 and 50 Fahrenheit outside air temperature. That's where most energy is being used. And at very cold temperatures, there's a lot less. So even though the intensity is much higher, since there's less hours, there's less total energy. And so the orange line is the total, and the green line is what would it be possible to electrify and decarbonize if we had ways to generate heat at 160 Fahrenheit. So that gave us a first impression of, okay, we would be able to let's say generate half of the heat, or a little bit more than half of the total heat with water at 160 Fahrenheit, but there's still a lot that's out of reach, that's at higher temperatures. Next slide, please. So that gave us, that's another graph showing the same data, but per building now. So we see for each building, if we were able to generate hot water at 160 Fahrenheit with heat pumps, what would be the fraction that is electrifiable? So the building loads that's below 160 in green, and the building heating loads that's above in orange. Next slide, please. So that was only the starting point. Then we took the analysis a step further, and instead of focusing only on 160 Fahrenheit, looked at the various different potential temperatures for hot water. So here you see 4 vertical lines that represent those temperatures. The red one is represents maybe the status quo in most buildings, 185 Fahrenheit. Then the orange line would be 170. A lot of heat pumps can operate at 170, although not as much as at 140, for instance, the yellow line, and 120 Fahrenheit, the green line would be ideal in terms of efficiency of electrification of heating. However, as you can see, a lot of the buildings loads, the buildings are represented by the bubbles. They're all past 120, and even most of them beyond 170. This graph shows the where the energy is being used. However, at very cold outside air temperature, you see at the top where it's showing 5 degrees Fahrenheit. So if we go to the next slide, with slightly warmer temperature, we see that the bubbles start to shift left. And so this is what it looks like at 35 Fahrenheit outside air temperature. And next slide, please. At 65, a lot of the bubbles are within range of, or within between 120, 140, and 170 for the most part of the heating load in the building. So that's, through analysis of that data. Next slide, please. We're able to develop so that was the energy side, and now on the building side, through our knowledge of the buildings, we're able to develop rules of thumb for cost of conversion of a building, for radiant heating systems like radiators, peripheral unit, perimeter heating units, cabinets, or fan coils, versus ventilation systems, so air preheating and terminal reheat. So we find by experience that the radiant side is more expensive to convert than the ventilation side, and so for certain types of buildings, for instance, dormitories versus academic buildings, we're able to develop these equations that give us a sense of the cost to convert the buildings to various temperatures. So we'll have different, an increasing cost of building conversion for a greater reduction in temperature of the building heating system. So that's the idea. Next slide, please. And that takes us to these are all the buildings, or not all of them, but these are actually not buildings. These are heat exchangers, or zones that, and each zone supplies supplies heat to multiple buildings on the at the bottom on the x-axis, and then you see then some cost estimates, although the costs aren't shown here because the analysis is not complete. But you can see that cost goes up if we're targeting reducing heating to 120 Fahrenheit versus 170. and this is based on the kind of the data-driven analysis and per building or per group of like buildings analysis that we've performed at various temperatures, temperature hot water targets. So that's in a nutshell that summarizes some of the approach that we've taken as part of this exercise focusing on the buildings. And like I said, this is one component of many of a much larger problem, but we're making progress. Back to you, Bob and Jess.
Thank you, JP. A lot of really good information there. Too much for the allotted time. I'll summarize Brown's journey, like most other campus journeys, is it's simple but not easy. This roadmap, it's a very iterative process, and what we find in all of the successful roadmaps or organizations who are achieving the decarbonization goals, there are really three ingredients, the recipe, and the first one is a strong internal and external collaboration. The second is a shared alignment across the internal stakeholder groups. And the third is a strong partnership or strong partnerships that bring results-driven innovation for the design and the project delivery.
So the next handful of the lessons learned, I'm going to talk about just really briefly. It was really important for Brown to have to engage with firms and people that we had long-term trusted partnerships with. A great example is the ecosystem. We had a great experience with ecosystem in regard to the thermal efficiency project, as well as some smaller other small projects on campus. So that trust had been built, and we felt comfortable engaging with them along with the other engineering firms for this really important undertaking that carries a lot of risk if we don't do it thoughtfully and carefully. Innovation was a big piece of our conversations. It was important for us to have people at the table that thought big and thought differently, that looked across the globe in terms of what was up and coming in terms of technology and approaches. That's one of the places where ecosystem really shines from our perspective. The other thing is to base goals on operational and financial models. There are a lot of institutions and organizations out there that set greenhouse gas emissions goals, but they don't do the upfront work to see that it's operationally and financially feasible first. And that was our first step, to get people around the table, everyone from our finance folks to engineers to our operations department, to map out kind of a basic schematic of what these things would look like, and could we do it from both operationally and financially in that time frame. The next one is visionary plans can be surprisingly accurate. Again, I'll keep reiterating having the right people in the room. It's a little scary to go after a visionary plan, knowing that there's going to be a lot of changes along the way. But our original plan has been, while it's been flexible and has changed along the way, it hasn't changed in any drastic ways. Dividing and conquering, as you remember, I talked about the approaches. There were a lot of different people around different tables. So I talk about sourcing the renewable energy. That's a whole different group of people than the decarbonization engineering approach, which is different than the people talking about offsets. But the one constant throughout all of those groups is the Office of Sustainability. So we're really connecting all of those pieces. And then we say it over and over again, is to stay flexible, that there's so many changes on a campus. There's so many changes on a regular basis, new construction, renovation, donors, maintenance, unexpected maintenance, those types of things, along with the external, which are new technology, new ideas, and new approaches. So it's so important to stay flexible, because you could really miss out on a lot of opportunities if we didn't. So with that, I think that is that's the end of our presentation, and want to thank you for taking the time today. And here's our contact information. Feel free to reach out to any one of us with any questions, and we'll be happy to get back with you.